Alright, let's continue with more transformations on sine and the cos function. Today the focus is to look at the vertical translation, which is the way it's worded in the textbook. It's parallel to the y-axis, but it's a vertical one, so it either goes upwards or downwards. The two things we're gonna focus on is the vertical translations with the graphing, the way it compares to the regular sine or cos. It will also affect the range of the function. And the last bit is we're going to go back and solve trigonometric equation to determine the one or several x-intercepts. Um, Intercepts are always, it's critical information you need to provide every time you do a graph of a function. So with the first one, you have those two functions. Let's break it down a bit. You're going to use a CAS to help establish the shape. I'm just going to break it down a bit for you to get started with the graphing. You will have the domain, you have your two dilations, so 3, 2. The minus pi on 4 is your translation to the right. Anything I talk about transformation relates to the original sine function. Okay, now what's new here is going to be your plus 2. This is where your vertical translation fits in, and what it does on your graph is when you have a plus 2, you should think about drawing your line y equals 2. And for a sine or cos function, that's negative 1, it represents the median value or the zero line. Okay, so the median value originally, if there wasn't a plus 2 here, it will be your t-axis. And next, what I would think to do, let's go with the range first. So with the range, you have your dilation factor from the t-axis, which is 3. So from 2, if you add plus 3, you get your 5, and a 2 with a minus 3, you get your negative 1. So your range is from negative 1 to 5. Okay, here negative 1 minus 2 is negative 3, and negative 1 plus 2 is positive 1. So here's your range for the cos function. Okay, what's new about that vertical translation as well is, and we're going to see that later on, as you shift the curve up, you can see the x-intercepts are changing. Okay, they're no more on the t-axis because we shift the curve up. You have two new x-intercepts. It's going to be the same for the cos function here. The curve is shifted down, and your x-intercepts value will change as well. Okay, the rest is going to be similar. So the 2 here is your dilation of factor 1/2 from the y-axis, so it will affect your period. So remember your period, I write it down because it's something students tend to forget. It's 2 pi over n, and n here is 2, and here your period is going to be 2 pi over 3. So remember, a period is a full cycle. If I start at this point, and because it goes across 2 pi over 3, I do a full cycle going downwards to the minimum and back to the same point, and that distance from here to there is a full cycle, or 2 pi on 3. Okay, next one. You need to sketch the graph, so it's from 0 to pi on to 2 pi. Clearly indicate the x-intercepts, and that's what we're going to focus on today. Now, before we do this, 0 to 2 pi, always calculate the period. Okay, so the period is from it's 2 pi here, because 2 pi divided by 1. Here is pi. 2 pi divided by 2 is pi. It means you need to draw 2 cycles here, and here is the same, it's pi. Again, 2 cycles. Because you have 2 cycles here, the number of solutions will be affected. Usually you get, in general, most of the time you get 2 solutions per cycle. So here we should get 2 solutions, and then because you have 2 cycles, you should get 4 and 4 here. Usually there are exceptions. Next bit is determine. Always think about the range. So the range here is going to be 1 plus root 2 and 1 minus root 2, which gives you your minimum and maximum as well. So your range here, hang on, wait, yep, is from 1 minus root 2, which is negative, and 1 plus root 2. Okay, and similarly you get the same for the others. Okay, so to determine the x-axis, you look at part A. You make the y 0. So that was your y for your function, but this time you make it 0, and that becomes your equation. And you solve for x. So remember, when you have a trigonometric equation, first make your sine or cos the subject. So that becomes sine of x equals negative 1 over root 2. One of the solution, think about the positive. When you have sine of x equals the positive 1 over root 2, it's coming from your exact values that you need to know. It's pi on 4. This is the solution theta from your first quadrant. Your solution to be negative needs to be in the third quadrant. Wait, that's not a theta, it's this one. And the fourth quadrant, that one. You simplify your answers in terms of pi. That gives you 4 pi on 4 and 7 pi on 4. That will show down here. Okay, and remember, you have a full cycle, and graphically you can see that you intersecting the x-axis here twice. So you have 2 solutions, and we found all the solutions. Remember the minimum here and the maximum, and your starting point 0,1, easy to determine. You just substitute x equals 0 into your function, and you get your starting value. If you add the full period, plus 2 pi, because it is a periodic function and the full period is 2 pi, that value gets repeated 2 pi later to the right, and also you would get the same if you were to go to the left. Alright, with part B, a reminder again, the period is pi. Now we're going to draw, actually graph 2 cycles, so you should get 4 solutions. Make the function 0 again, make cos the subject. You're gonna have to do a temporary substitution, or just make 2x equals to that. It's positive, and the main solution is pi on 3, which is your theta. Okay, The next cos value, this one, is coming from the fourth quadrant, which is 2 pi minus theta. And the others, you just add a full cycle, so you add pi. So remember, the period is pi. So once you find one solution by adding pi, you can find the next one. The second one is coming from the fourth quadrant. You add pi to get that 11 pi on 3. That was those four solutions for 2x. You divide by 2 to make x the subject, and you get those four solutions in terms of 6, which are your four x-intercepts. So pi on 6 is this one, and the other three, and so on here. Okay. Part C, we're going to repeat that. Same process. By making this equal to 0, you make sine the subject, so that gives us root 3 on 2, which is positive, and that's sine of pi on 3, which is your theta. So the first one is your theta in the first quadrant. Determine the next one in the second quadrant. So you do pi minus theta. To get those ones, you add pi to the first. The second one, you add pi to get the last one. Okay. You get your four solutions for that left expression. Now we need to rearrange that to make x the subject. So we divide by 2, and then we add plus 3. So it's a little bit of a linear equation by transposing until you get x as a subject. The first one, pi on 2, is up here, and you can add the other three on the graph. Remember, with your graph you have a minus root 3, so it's a vertical translation from 0 to negative root 3. You can also determine your maximum by doing, this one is 2, it should be 2 okay, so it's negative root 3, and the dilation from the x-axis is 2, so it's negative root 3 plus 2. They rearrange it to 2 minus root 3, and this one is negative root 3. That's your middle value, minus 2. Okay. Your starting point, you substitute x equals 0, and you evaluate that, and that will give you your negative 2 root 3. And that's it for 14J, and I'll see you in the next video.